Well, Bill Frey, Regional Sales Engineer at Harmonic Drive. Welcome to the podcast.
Well, thank you, Tom.
It's great to have you here. We're going to talk a bit about the future of surgical robotics. And I want to understand from sort of a global or more holistic perspective where surgical robotics fits in to other industries. And you're a great person to talk about that. Bill, talk a little bit about your background. Where you're focused now on surgical robotics, but you've worked across aerospace and semiconductors and other industries as well. Where's your career taken you in robotics?
Well, what's interesting about our products is they're used in a variety of industries. And so in 1 week, I see applications in all different industries, one of them being medical, but certainly in robotics in general, and in factory automation. And it makes it very interesting to have many different applications for our products. And
you've had experience in those industries as well? Past experience?
Yes, I have. And specifically, I worked for a few years designing actuators for space flight.
Wow.
So, I have quite a bit of experience in that industry as well as selling into that industry as well.
So then you help me understand where surgical robotics fits into sort of the broader robotics landscape. What makes surgical robotics uniquely demanding from, I'm going to ask what makes it uniquely demanding from a motion control standpoint, but within that answer, I'd love you to kind of give me and our audience a sense of what motion control means to Harmonic Drive.
Well, our products have a unique characteristic to them that they're extremely accurate and they have high repeatability and very, very high reliability as well. So for that reason, they're used in a lot of these applications where failure is not acceptable. For example, so I mentioned spaceflight before. If something's up in space and nobody's going up to fix it, basically, to put it bluntly. In the case of a medical device, it's extremely important that it's reliable and it's repeatable, and it has very high accuracy, in our case, zero backlash gearing.
And you're also not sending out surgical robotics that blow up and use that as a learning experience, as we've seen SpaceX do more than a few times. So when people talk about surgical robotics, I think we've been talking a lot more about visualization and software, but give us a sense of how foundational the mechanical precision layer underneath all of that. How important is that?
Oh, it's very important. You may have seen test apparatus where they're simulating an operation by picking up little tiny objects, and it's very hard for the end effector to actually pick up these objects. And operator, the surgeon, is operating them remotely. They're not actually, the fingers aren't in there. So the reliability, the repeatability and the backlash is very important.
In surgery, though, smooth motion, I think it's more critical, no pun intended, more life-saving technology. What actually goes into what parts and what process goes into ensuring that you're able to eliminate backlash and vibration and any kind of herky-jerky feel? And then maybe after we can sort of unpack what are some of the products that help us get there?
Well, there's a few things. So the mechanical transmission, for one, so from the motor side into the actual output, as well as the position feedback. So the mechanism needs to know where it is at any given moment. So you have some sort of feedback mechanism. For example, an encoder. You may have a torque sensor involved as well.
In what is the function of the torque sensor?
It's to provide feedback of the torque that's on the output side of the arm.
So with surgical robotic systems and surgical robotics arms, I would think that you're working at a much smaller scale. How difficult it is to build something that has all these components and elements that are necessary for that smooth motion in something that must exist at such a small scale?
Well, a lot of this is it's designed by the medical manufacturer. The medical device manufacturer, because there's nothing that just exists on the market. So in this case, typically a lot of different components are assembled and tested to achieve what they're looking for.
One thing that's always fascinated me about surgical robotics is that industrial robots, they sort of are execute to program motions that are necessary to sort of complete something, complete a car, or now move a box or whatever they're doing in other industries. Surgical robotics sort of amplify the human hand, the surgeon's hand. How does this fundamentally change sort of the mechanical requirements of a surgical robotic system, and how does Harmonic Drive help with that?
Well, it's you have a good point. It's not just a mechanism that's just picking up something, repeating the same motion over and over. In this case, it's driven by an operator surgeon, and they need to be able to control the device as if their hands are at the end effector. And when they want to make a move, they want to have very quick and accurate movement on the output, which is to what the move that they commanded. In addition, a lot of these devices may have haptic feedback, where they actually have some sort of resistance at the control, which is proportional in effect to what's seen on the end effector.
Let's drill down a little bit on haptic feedback. That's become obviously it's been a point of conversation for years, but I think more importantly, more recently, it's become seen as sort of a differentiator between surgical robotics, some surgical robotic systems, one from another. As haptics and force feedback evolve, how important is the ultra precise gearing that goes into providing that enables that surgeon experience, that allow them to sort of quote unquote feel the tissue that they're working on?
Yeah, it's very important, because if you have any kind of backlash or lost motion in the system, as you're trying to operate it, you're now missing your spot on the output side, on the end effector. So this applies to even just like a pick and place type of unit, where if you picture that here you are with a joystick trying to pick something up, and you're trying to go to a certain spot, but you have lost motion, you have some backlash, you have trouble achieving what you're trying to do. And it's in this industry, it's even more important than what you might see in other industries.
Is that sort of feedback unique to surgical robotics, that sort of you need to feel what you're quote unquote touching, or have you seen that in other industries as well?
Certainly in other industries as well. Yeah.
I always thought that was something uniquely tied to surgical robotics.
Well, typically in an industry where it's a human operating it. Obviously, I suppose, but in like a pick and place device, or some kind of thing where the operator is actually trying to have dexterity on the output.
So I mean, we've seen a lot in other industries or in other technologies that things develop faster in industries outside of medical devices, for the simple fact that, well, I think the stakes are higher maybe here than elsewhere, and it's also highly regulated. And as a result, I think medical device companies are able to learn lessons that have been experienced in other industries. Final question: What lessons from aerospace or semiconductor precision systems can surgical robotics learn from and maybe adopt more aggressively?
Well, it's certainly an industry that's growing and utilizing a lot of knowledge from other industries, and it's a case where the lessons learned from the robotics field is being applied into new industries, such as this one. Specifically, there's probably a lot more behind the scenes than I'm aware of. Usually, I have customers asking questions for the various applications, but why they have their requirements sometimes I'm not fully aware of.
Do you think are there areas within surgical robotics that are blazing new trails and are doing things that you have not seen or others have not seen in other robotics industries, or are our experiences again paths that others have already sort of blazed, or trails that others have already blazed?
Certainly, there's new developments coming out, and new technology being used, and new applications, new types of approach to achieving solutions. So it's exciting. It's always growing, and it's always different.
We're seeing a lot of innovation and a lot of advancement, I think, in surgical robotics of different form factors and different applications over the last 5 years in particular. What do you think's drawing? Where do you think that energy is coming from? That's drawing all of these new technologies, both from larger companies and small, into our consciousness and eventually onto the marketplace in the future? Is it just, do we see from other industries, maybe you've seen it before, do you see a critical mass of great ideas just sort of coming together, coalescing, and just pushing an industry forward? And are we at that point with surgical robotics?
I think we are at that point, and it's a lot of these ideas have been floated around for years, but now the technology's caught up, and so now with the products that are available now, the technology, the capability of computers and everything, and also the general acceptance of the concept of medical devices being automated. It's a whole new world now for this.
Yeah, that's a great point. I don't know if you've seen. I wouldn't say there's been a resistance to surgical robotics, but there certainly has been a skepticism maybe that you don't see in other industries. Maybe other industries are more open to these new technologies coming in, whereas we're more of a show me sort of industry. Do you get that sense that there was a hurdle of cynicism or skepticism that had to be overcome?
Yes, I do. I don't know how to describe it so much, other than originally, robots were used in factories doing repetitive tasks that typically were sometimes a dangerous task. Is well suited for a robot, but in this case, it's not so much a dangerous task, but just a really high demand and very important task that now they're looking at a robot for, or robotics in general. Mm-hmm. So there was, even though there's, surgical robots aren't new and medical devices aren't new, I think as time goes on, it's more mainstream now. It's not surprising when you hear about them.
That's great. It must be an exciting time for you to be part of surgical robotics right now.
Yes, it is.
Excellent. All right, Bill Frey. Well, thanks so much for your vision of the future and for joining us on FOMO.
Thank you, Tom.